clouds, and then you went farther and you saw altostratus clouds, and then you saw nimbostratus clouds and light rain showers, and then it went and you were in clear air. What kind of front did you just drive across? Well, you drove across a warm front in that case, right? I like those kind of questions too, where they show that you can put together what you saw out of there. I respect questions like that. Let's probably more of that. People have lots of stress about dry lines, and they have lots of stress about occluded fronts. I like how this diagram shows a dry line associated with a cyclone, but don't get your hopes up that that's what it normally looks like. Every now and then okay, are we in agreement? This looks like a cyclone. If we forget about this guy for a minute, this looks like a cyclone, right? You got a cold front, you got a warm front, they're meeting here, there's a cyclone. There's a nifty word for a cyclone in this stage of his life. We call it an open wave. All good, right? Notice that in this case, they've got a dry line here where continental tropical, hot, dry air is coming off the deserts of northern Mexico and West Texas and so on. And maritime tropical air is coming up off the Gulf of Mexico, and they're separated by this dry line. That's lovely, but this business of it connecting up into the middle of the cyclone, that would be, it happens from time to time, but that's not normal. That's just sort of them putting two things on one slide. Okay, that was yeah.
One of the questions on the homework was, what's the similarity between a cold front and that dry line?
Yep.
That they both move.
Well, okay, that would be one. Actually, but I'm not quite entirely sure what that question's all about. I mean, there are certainly those similar in a number of ways. What are some ways in which dry lines and cold fronts would be similar? Well, they are both sloped with respect to height, with the more dense air mass nearer the surface and the lighter air mass being running over the top. That they move is an acceptable answer to that. Let's see. They both are, you would expect to have rising motion and thunderstorms on their leading edge. That would be another one. You have to admit, when I always mean to call that question when that one pulls up as being one that goes on this semester's homework, and I've missed it this semester when it came in, because I'm never quite sure what whoever wrote those questions was looking for that time. Okay. People get a little scared about dry lines. Hey, which of the two air masses, the dry one or the moist one, which one was more dense? That was on your quiz. The dry one. Yeah, the dry one is more dense. The moist one is lighter, the dry one is heavier. Oh boy, there's a whole lot of unhappiness about that. Make sure you know that. That will definitely be there in some form. Folks are also usually pretty bent out of shape about occluded fronts. I really, really, really like this diagram. I don't think this is from your textbook, although your book has something very similar to this, where we show cross-sections, in this case through an open wave, and then through an occluded cyclone, and then through an occluded cyclone that is really, really old. I mean, you can see his occluded front is getting really, really long. And notice how you can relate that to what the cross-section of the atmosphere. Oh, I love these pictures. There will definitely be questions that involve understanding what's going on this picture. I can't tell you exactly what the form of the question is or whatever, but they tend to be fairly hard questions. Sometimes some of the questions in the pool do involve there actually being a picture like this on the test, although, for example, one could envision, I'll tell you because this question is not on the test, but it gives you a sense of the kind of things we can ask. There are questions on the test where these kind of cross-sections are provided, and then you need to tell me, they don't, is that from here to here, or is that from here to here? Like, I have multiple lines labeled on here. Is that the one line from A to B? Is that the line from C to D? Is that the line from E to F? Whatever. So make sure you understand this business of an occluded front as well. It tends to be the one that people hope I don't ask about. I am asking about it. Hopefully, I apologize for the fact that I became quite the spammer yesterday. Every time I thought I had everything taken care of and sent an email message out, somebody would send off a question, hey, didn't you tell us you're going to give us a handout about this? Crap. Didn't you? Whatever, so I take care of that, then another one. And so it just became kind of crazy. But hopefully you got those handouts that I send out about what cyclones do and don't look like. Again, I don't remember, I know that there are questions in the pool, though there are the kind of thing I've got 4 things drawn on there and you have to tell me which 2 of those are realistic cyclones. Or what's wrong with the one that I drew in figure A? It's got a high instead of a low in its center, or something like that. Okay. knowing this business about comma clouds is important. Well, I don't know if I would say that was important. I would say it's important in the sense that, you know, it's maybe 2 questions or something. But who doesn't need the 2 points, right? So make sure you do it. Again, I put a gallery of, I thought I'd just go ahead and start doing that, and every time I see a good example of a comma cloud from now on, I'll just keep adding it to that PowerPoint stuff. So, you know, that had some examples of comma clouds. You can download that from Blue Line as a course announcement, and you'll see lots of examples of what they look like. Again, it isn't like we're going to have a diagram like this, and it's going to say which of these things is the comma cloud. Okay, that would be like roughly the one. That would be basically a question that's just testing if you have room temperature, if you've achieved room temperature. Okay, if you get that one wrong, you wouldn't be really in the class, right? There are questions more about like what this comma cloud is, like how big is it, what is responsible for the narrow part of the cloud band, what's responsible for the big wide part of the cloud band, stuff like that. Technically called the cloud shield. Excuse me, going from hiccups to this tickly cough now. I once again provided these diagrams they had up there on the projector that are the life cycle of a cyclone, where we started off with that occluded, that stationary front, and by the process of cyclogenesis, we had a cyclone develop along it, and its rotation produced, well, it changed that stationary front into a cold front and a warm front. This would be a good example of a situation where the cyclone is an open wave. Here's another good power vocabulary word that we used last time. We talked about this section of the cyclone being the warm sector. It is where the warm air mass is. This is where the warm air mass is getting dragged by the cyclone up to the north, whereas the cold air mass is coming down on the west side of the cyclone. That cold front moves faster than the warm front, so with time it starts catching up. The warm sector gets narrower and narrower, and eventually you get an occluded front, where the cold front has caught up with the warm front. And of course, this is where the cyclone has begun to die. It's begun to experience the processes of cyclolysis and cyclogenesis, which again, can't possibly be important because Dr. Shragi only put 10 minutes of video about such a thing up and only gave us PowerPoints and also gave us handouts about, no, he probably won't ask anything about that, right? No, it was like 20 minutes of the lecture or a half hour of the lecture last time we met. It's going to be like 10 questions or something on the test. Well, maybe not 10. 5 to 8 or something. Obviously, it's important. What kind of powerful vocabulary words did we have when we were talking about cyclogenesis? Well, first off, cyclogenesis is fundamentally about the mid-latitude jet stream. The mid-latitude jet stream is the one that experiences cyclogenesis. The tropical jet stream, it doesn't have fronts, it doesn't have the thermal wind relationship going on involved in. We don't get this kind of weather feature involved in the subtropical jet stream. We got troughs and ridges. Remember those 2 words? Here's an example of a trough. It's a place where the flow was headed to the south and then made a left turn, and now it's headed to the north. We got a ridge, a place where the jet stream was headed to the north and made a right turn, and now it's headed back to the south. Well, that jet stream stayed above the front at the surface by the thermal wind relationship. And we talked about the fact that because of that jet stream having troughs and ridges, it has regions of positive vorticity, negative vorticity, and zero vorticity. At an ATS 113, just beginning to learn about meteorology kind of level, it's enough to know that vorticity is about spin. Vorticity is actually a little bit more complicated than spin, but spin is a big part of the story. Something like a tornado has a lot of vorticity. Something that isn't turning at all has no vorticity. It's actually defined so that counterclockwise spin is positive vorticity and clockwise spin is negative vorticity. That area between the trough and the ridge is an interesting place. That area has zero vorticity, and the air that's coming towards it has positive vorticity. It's got to lose that vorticity. That region is experiencing positive vorticity advection, meaning that the air that's coming has more vorticity than the air that's there now. We are advecting positive vorticity, but, I mean, that doesn't mean the vorticity is going to increase. It means we have to lose the vorticity. Well, we talked about the fact that how do you